Hello students. In this video we're going to talk about calculations with significant figures. The central idea here is that the result of a calculation based on measurements can be no more precise than the least precise measurement. You need to know that different rules apply when adding and subtracting versus multiplying and dividing using sig figs. Let's look at rules for multiplication and division. So when multiplying or dividing, use the same number of significant figures in your final answer as a measurement with the fewest number of significant figures. Use rounding rules to obtain the correct number of significant figures. So let's look at this problem. We have 110.5 times 0.048. So we have 4 sig figs here, 2 sig figs here. Remember, leading zeros are not significant. Captive zeros are always significant. Okay? So when we put this in our calculator, we get 5.304. Alright? So to report the answer to the proper number of sig figs, we're going to report it to the least number of sig figs that's in the problem. So 2 sig figs. So this would be 5.3 reported to the proper number of sig figs. This is 0, so we can't round the 3 up. So this 3 remains. Okay? So that's when you're multiplying or dividing. Remember, focus on the fewest number of sig figs that's in the problem and report your answer to the fewest number of sig figs. Addition and subtraction. When adding or subtracting, use the same number of decimal places in your final answer as a measurement with the fewest decimal places. This will be the least precise measurement. Alright, use rounding rules to adjust the number of digits in the final answer. So let's look at an example of this. Here we have 25.2 plus 101 or 101.34. So when we plug this in our calculator, we get 126.54. Okay? So let's look here. Fewest decimal places. Which of these has the fewest decimal places? Well, it's going to be this guy, this 25.2. And so that's going to represent our least precise measurement. This has 2 decimal places compared to 1 decimal place. So we're going to report our answer so that it reflects 1 decimal place. So this would be 126.5. This is not 5 or greater, so we can't round this 5 up. So we leave it the same. So it's 126.5. So it's a subtle difference when you're adding, subtracting versus multiplying and dividing. When adding and subtracting, you want to focus on the fewest decimal places. Okay? Like we did here. Okay? Fewest decimal places when adding and subtracting. Okay, so what about when we have math operations that are mixed? How do we deal with that? If you have both addition and subtraction and multiplication and division in a calculation, follow the rules for order of operations. Remember, parentheses come first, followed by exponents, followed by multiplication and division, followed by addition and subtraction. A way I always remembered it was, please excuse my dear Aunt Sally, or PEMDAS. Okay? And whenever you have these math operations that are mixed, complete the calculation by rounding according to the rules for the final type of operation that you do. And you tend to want to save your rounding until the end, because if you round too early, you begin to introduce errors which will get you further and further away from your correct value. Okay? So let's look at a problem that involves math operations that are mixed. So here's a density calculation that we're going to do. So we have 5.681 grams divided by 52.15 milliliters minus 32.4 milliliters. Okay, and so this is in parentheses, so we're going to carry this operation out first, right? So 52.15 milliliters minus 32.4 milliliters, that difference will give us 19.8 milliliters. Notice how I report this 19.8 milliliters to one digit after the decimal point, because in this operation the 52.15 milliliters, 2 digits after the decimal point, the 32.4 milliliters, 1 digit after the decimal point. So when I take this difference, I'm going to report my answer to 1 digit after the decimal point here. So 19.8 milliliters. Alright, so now that I've done the first operation, now I can move to the second operation, which will be division. So 5.681 grams divided by 19.8 milliliters. 4 sig figs for 5.681. 3 sig figs for 19.8. So when I report my answer to the proper number of sig figs, it needs to be to 3 sig figs. So when we plug this in our calculator, we get 0.286919192. And so to report it to the proper number of sig figs, so this would be 1, 2, 3 sig figs. Remember, leading zeros are not significant. So I look at this 6 here, and I look what comes after that 6, and it's a 9. So remember, if it's 5 or greater, you round up. So I would round this 6 up to 7. So my final answer would be 0.287 grams per milliliter. Don't forget the units. Alright. So I hope this video was helpful to you. More videos to come. And happy studies.